Well, let's get started. Just for those of you that are joining us tonight, this is Doug Shoemaker, and I've been doing the talks here for about 15 years. And as most of you know, we do video, record them, so they'll be up on the YouTube maybe probably about a month after the presentation. And so that's one thing to keep in mind if you know people that would be interested in this talk tonight, which I think is going to be fantastic. The only other thing I wanted to mention is that we do have, as Lauren and I were just talking, we do have a solar boat regatta. What is it, Mark? The 34th? Well, anyway, I think it's the
Yes,
34th.
it's the 34th boat regatta that MRES has put on, and it's
Okay.
May 16th.
Yep, May 16th. And we're looking for schools that might be interested. So if any of you have contacts with your local schools, we do have solar panels that we can lend to them to get started. We also have some electric trolling motors, and we have a student class and an experimental class. And so some of the new participants usually start out with the student class and then, after a while buy their own stuff and become involved. So anyway, just please keep that in mind. And like Lauren said, May 16th, and it's, well, in Minnesota, it's always interesting. You never know if you're going to have ice on the lake yet or not. So, so well, anyway, let's get started tonight. I'm so excited to have uh, uh, Dr. Moustafa presenting to us tonight. He's assistant director at the University of St. Thomas Microgrid Research Center, and he's got some amazing information to share with us. So with that, would you please go ahead?
Yes, thank you, Doug. Thank you all for this opportunity. I'm happy to be here today and to represent the center. For microgrid research and University of St. Louis. So our microgrid as the backbones for Minnesota 2040 carbon-free grid. So these are the outlines of the presentation. We'll start talking about Minnesota power grid. We'll start with the US power grid and we'll focus more on the Minnesota one, status and challenges currently facing. And then we'll talk about the Center for Microgrid Research. We'll talk about the capabilities we have and the microgrid we have. And then we'll move to some exceptional developments in the area of microgrid. Now like lots of AI happening around the country. So that put lots of stress on the power grid. And then we'll end up this presentation by pathways to the 2040 plan, which is I consider it one of the most important items in this to satisfy this plan is the workforce development.
Yeah. Oh, excuse me, just one
Yes,
minute. Do you
please.
like to have questions as you go, or just wait till the end of your talk?
We can wait till the end of the talk. So that,
Okay,
yeah, it would be
let's do it
to
that way tonight
keep the
then.
flow.
Okay.
Okay,
Thank
okay.
you.
Thank you. So first of all, like the U.S. electric grid, it is considered like the world's largest machine. It includes like around 7,300 plants, over 60,000 miles, 160,000 miles of high voltage transmission that include AC transmission, DC transmission, and all types of power plant. So if we go to you see this pie chart, we see that recent or the latest statistics from the U.S. Department of Energy, it shows that around 38% of the plant from the power comes from natural gas plants. We have like 22% from coal, 19% nuclear, and 20% renewable. So we have three largely independent interconnections. the eastern interconnection east of the Rocky Mountains, which is, as you can see from the map, it is the largest one. And you have the western interconnection west of the Rockies, and of course Texas. Texas has a very unique power grid structure and interconnection with the other states, because Texas has its interconnection with the other states is mainly done using high voltage DC back-to-back systems, which is very expensive, and in the same time they keep their grid somehow secure if there is a blackout in surrounding states. So, in order to achieve the goal of having a cleaner generation of energy, uh, we have to build like around 5,000 miles of high voltage transmission, and also to try to overcome the existing challenges in the power grid in the US. Uh, I summarize the main challenges that the US electric grid is facing, because this also will be implying on the Minnesota grid. Aging infrastructure, so all the power stations, transmissions, and all of that, it's suffering now from aging. And the second challenge is the surging demands. So there is lots of demand now for power, for electric power in general. You see EVs around. You see now they are building data centers and all of that that needs lots of electric power. And besides the surging demand, we have a changing of demand. Like years ago, most of the demand were mainly either industrial or residential. Now we have different types of loads now, coming from data centers, from EVs, and from all of that. So that's what's meant by changing demand. If we take a closer look, we leave the US broader look, we go to the Minnesota grid. So the Minnesota grid is primarily is operated by MISO, the Mid-Continent Independent System Operator. And if we take on the closer look about the sources of power that uh, form the power grid in Minnesota, we see that change from 2014 till 2024, which is 2 years almost ago. We see like we had like 49% of power coming from the coal power station. Now this is has been to 20%, which is very significant, like in 10 years. And we had like 22% coming from nuclear. Now it's around 20%, so it's almost kept at the same level. Almost, it's reducing a little bit, but it's kept like within a certain level. And we see like the gas power stations, it's has been increased from 7% to 27%. So if you take a look here on the numbers, you will see that almost the gas power station has somehow compensated the coal over 10 years long. And of course, there is a significant increase of the renewable energy from 22% till around 33%. There are key interconnections, and with from west and northwest, it's coming from North Dakota to Minnesota, including the HVDC line. And there is another interconnection to Wisconsin. So east to southwest, it's high voltage tie. And we have another line coming from Manitoba in Canada also for to import power from Manitoba Hydro in Canada. Besides the previous challenges we went through in the previous slide, there are some other challenges in in Minnesota. So this is what's known as vulnerable nodes. We have like the rural co-ops and end-of-line neighborhoods can see some high outage risk, especially like in the rural parts of Minnesota. And also we have another blessing is the extreme weather events which can happen, which happens sometimes in Minnesota. So it can cause like a cascaded outage, and that will affect the health and the safety of the community itself. So Minnesota took a very ambitious plan in 2023 to have what's called like 100% carbon free law. So, and as I mentioned, 2035, which is like less than 10 years from now, we will have like 90% carbon free, and 2040 will have 100% carbon free. So by in 14 years from now, we should be retiring all carbon resources. So all the coal plants that represent like around 27% of the power generation in Minnesota should be uh, retired by 2040 for sure. And the plan is to add more renewable energy in forms of wind and solar. And wind and solar, of course, these are renewable energy, so they come with storage capabilities as well, in order to take advantage of them during the all around day, all the day around. So, so wind and solar are great, but they come with some with them. So we have, like as in Minnesota, we have to take care of these challenges and try to deal with them as soon as possible. So plus resilience alongside with new clean generation. Among the possible solutions here is to use a microgrid. So what is the definition of a microgrid? Microgrid is basically like a small power grid. So it is a group of interconnected loads. You have loads connected to the grid, and in the same time you have multiple what is called distributed energy resources, or DERs. DERs is one of the very popular terms in microgrid. So as you see in the figure here, we have multiple types of generation. We have solar, we have wind, we have diesel generator, we will have storage for sure, and we have multiple loads. So these loads can be industrial, can be commercial, can be residential. And there is like a center of control which manage all of these DERs with the loads. So usually a microgrid, as I mentioned, it's like small power grid, so it can operate in parallel with the grid. So this is what's called like grid connected mode, and it can operate by itself using its own resources, and this is what's called islanded mode. And this is normally it happens during outage or during like high tariffs for power um, imposed by the grid itself. So a microgrid, just to summarize, can operate either in grid connected mode with the main grid, or it can operate by itself or independent, which is islanded mode. So the microgrid offers like many advantages, but among them is the resilience. So it can keep critical loads running. So let's say we have an outage, blackout across the city or across part of the city. Having a microgrid will make all the critical loads, such as hospitals and maybe some bank servers rooms and all of that, running. Uh, Grid support, it can actually simulate the virtual power plant behavior. And one of the big advantages, it's speed. Speed, I mean here, you can build a microgrid within months or years or few years. You don't need to wait for 15 to 20 years to build a microgrid like the case of, let's say, nuclear power station. So this is one of the big benefits of having a microgrid, that you can go through the construction process till you take all the permissions. It goes very quickly. And the fourth advantage is you can get some cash back. Because when you sell power to the grid, you get money back from the grid. So I always say, like, think of a microgrid as your grid personal backup generator. But instead of having a noisy engine in the yard, it is a smart system of solar panels and batteries that talks to the main grid. Uh, then it comes to the most popular question we always get: is solar plus a battery can be considered as a microgrid? Um, this can be considered as a small microgrid, but in my talk today, and when we speak about microgrids, we refer usually to a system having multiple energy resources, multiple DERs that serve multiple loads. So solar plus battery is like, let's say, a small microgrid. But when we talk about microgrid, we mean like larger system, not just relying on solar, relying on other type of resources. Then we'll come talk about what we do at the Center for Microgrid Research at University of St. Thomas. We have an applied engineering research center focused on DRs and microgrid and grid modernization. And actually, we have a living laboratory for real-time controller and protection and communication and testing. And we also have workforce development. We always have workshops for students, for engineers from the industry, from even like from 40 plan we talked about in Minnesota. Sorry. And train the innovative engineers and technology leaders for the 21st century. And the vision is to be one of the applied engineering research centers in the area of distributed energy resources and the microgrid, enabling a secure, resilient, and carbon-free electric grid for the 21st century. So one of the very unique aspects at the Center for Microgrid Research, also known as CMR, is that we do what's called applied research or applied engineering research. So applied engineering research, it's different than when you hear about a university and the research at university, you think about some theoretical concepts that never got being used in worldwide. But what's different here is that we do applied research. So all what we do, we implement that in a real life or in a real setup. So this is what makes the mission and the vision of the center very unique. So in the next slide, we'll talk about the microgrid we have. Maybe some of you visited the center, so they had the opportunity to see the microgrid in real life, but I will provide some pictures about the microgrid itself. So let's start with the capabilities of the center. So as I mentioned about the definition of a microgrid, it can be grid connected to the main grid, or it can be islanded, so it can work on its own. So this is what we have. We have a connection with Excel Energy through a dedicated substation for the center. And then we have different type of distributed energy resources. We have solar panels on the roof of the building. And then these solar panels are connected to an inverter, and this inverter is connected to the main grid. And also we have a PV emulator. So a PV emulator can basically emulate the behavior or the performance of the sun. So this is usually done. We use it for research, the PV emulator, and also for some company if they do some testing and they have special solar profile, we can include that in the emulator itself. And you have lithium ion batteries for storage. And besides the lithium ion, we had the old ones that are the lead acid batteries, 480 volt batteries. And besides that, we have also like some diesel generators. A diesel generator connected also to the main bus bar. And we have some power research equipment, which is power amplifiers, and to do some P-hill research. And also, we are currently in the plan of installing a DC fast charging at the parking ramp of the University of St. Thomas. And we have a load bank. So the load bank usually serves for the testing itself. So through the test bay. So we have two indoor test bays and outdoor test bays. So you can, let's say you bring your equipment, you bring your inverter. So it's part of the microgrid and you have this load bank. So you can do all the testing needed actually. And currently, like the microgrid is powering two buildings on campus. First building called Facility and Design Center, also known as FDC, and the second building is a parking ramp. It's called APF. So far, this microgrid is powering two buildings, and the future plan actually, we are building now two other microgrids. And the plan is to power like South Campus buildings, like 9 buildings South Campus, using our own resources. So that's the future plan. So we'll have at the end like 3 microgrid. You have the one you can see now, and then we'll have two other microgrid. And I'm not sure if you know, but University of St. Thomas now has an arena, hockey arena. So it has 2 ice rings and 2 basketball courts. And the new microgrids will be powering also this arena as well. Um, uh, these are some closer picture of the key assets that we have. We had the solar system, we have the substation, we have the Excel Energy interconnection, we have 50 kilowatt diesel generator, load bank 320 volt ampere load bank, and we have the lithium ion batteries 30 kilowatt 60 kilowatt hour, and this is from the basement. Maybe if you visited the center you would have gone. That also we have world-class real-time test beds. These test beds, we have what's called like real-time digital simulators. So this simulator, these big racks, the red one and the black one in the back, are simulators that allows us to do what's called the real-time simulation. So instead of doing all the testing on a real equipment that we have, so we go one step before that, we stop it, we say, you know what, let's test it on a real-time simulator devices. And there are 3 major companies leading the area of real-time simulation. We have RTDS technology in Manitoba in Canada, and we have Opel RT in Montreal in Canada also. And we have Typhoon Hill, it's based in Boston, here in the US. So the Typhoon Hill is the red ones, and according to Typhoon Hill, that the hardware capabilities at University of St. Thomas, this is the largest. This is a quote from Typhoon, largest real-time simulator test bed within Typhoon network over 600 global university and utility customers. And from RTDS technology also, we got that this is the largest installation of the newest generation of RTDS real-time processing hardware at a US academic institution and second worldwide out of 240 institutions. So these capabilities are not just they belong to the center for sure, but we also do some testing for like other companies, they come and they want to do, and I will show that at the end of my presentation. They come and they say to us, you know what, we want to use these simulators to do some testing related to power system, related to EVs, related to anything. So we always welcome like companies and any industrial partner to come and to take to use these simulators as well. Um, One of the um, important parts of the running a microgrid to have what's called like the microgrid controller or the human machine interface. So HMI. So the HMI is basically like a central hub for monitoring plus and commands and allows asset dispatch PV diesel generator. And this represent also like a safe training environment. So as you can see here from the screenshot I took from the HMI, we have the grid, which is Excel Energy in this case, and we have the transformer, step-down transformer, and then we have a breaker. So this is a breaker we have in the basement in the previous picture I showed. And we have this is a point of connection or point of command coupling, and we have here like solar panels connected to a solar inverter and more solar panels, and you have the energy storage, and you have the diesel generators, and you have the lead acid batteries, and you have here the load bank, and these are the test bays, and these will be like the future resources we'll have. So in the control room, we are sitting in a control room in a very nice room, comfort. We can see what's happening in the microgrid. So we can see the power flow between the from Excel Energy to us and from us to Excel Energy, power flow in the solar, um, either P or Q. So that's a control center. And like I have to say that everything you see in this slide was built by the CMR team, the students and staff. And some of them are undergrad student, first and second year student, and you'll be impressed about the quality of work they provide and about the dedication they have for sure. So this was not a commercial, not a commercial company that built this for us. No, that was the CMR team, students and staff. So let me show you like a glimpse about the operation, microgrid operation. So I will show the black start here. Black start, it's one of the important features in microgrid. So let's say you have a blackout, you are disconnected from Excel. There is not, there is no power. So I will show you like in a real time how we start the starting sequence of the microgrid we have. So first of all, we start with the energy storage system, the batteries we use as a grid forming asset. So it start powering the main bus bar. So we close the breakers and then we power the main bus bar connected where the load is connected. So as you can see here, we have the battery is on. So the bus is energized. The main bus bar is energized. The bus voltage, the one in red, has the energy storage was on. And what happens to the ESS, to the battery's power? It went to negative because basically, like the solar energy is feeding the battery, it's charging the batteries itself. After that, we have the load. So both of them start supplying the load depending on the ratings, and we have a load step here, and we use the solar power to the max. And then we have a diesel generator, and this diesel generator comes and starts. So it started on here and it comes to the full capacity here, and it shares the load with other resources, with solar and the energy storage system. So this graph shows like a real-time operation, and in the next slide I will show you like a video from the HMI that um, explains this procedure about what we do here. Yeah. So you see here we are closing the breaker from the energy storage. So closing the breaker. So ESS breaker is closed. And then now we are closing the starting the inverter control. So pretty much switching on the inverter, turning on the PV inverter. So as you can see here, the power of the energy storage turned to be negative. So because the PV is supplying power to ESS, to the batteries. Now we are applying the load, a 50 kilowatt load. Some reactive power. So the load bank we have, it's an RL, not just an R. So the load is applied. So if you see here, you will find that the power is 41 and coming around 9 kilowatt from the solar. So the total is 50 here at feeding the load itself. Now we are starting the generator, turning on the diesel generator. Yeah, so that's the woodward control. So turning on the diesel generator by starting the generator itself. Generator takes time to synchronize with the main bus bar. So you will see here that the voltage and the frequency and the phase angle, both of them trying to synchronize with the main bus bar. So the breaker at the generator will be on until it is synchronized. So after it is synchronized, it is closed and it can feed power to the load. So now they are synchronized, it's feeding power. As you can see here, it's around 12 kilowatt power from the generator. And we have ESS 28.5 and 9.5. This is the 50 kilowatt of the load required by the load itself. So some exceptional developments in the technology and the application rephrasing the microgrid value. The first one, it's grid forming inverters we'll talk about, and then we'll talk about hardware in the loop testing, AI and data centers, and digital twin and long duration energy storage. Grid forming inverter, forming inverter. We have two expressions. We have grid following and grid forming. Grid following inverter is the one that we exist in most of the inverters now. They just follow the grid. Grid creating or grid forming inverter is basically adding a brain to the inverter. So the traditional inverter need an existing grid signal, voltage, a frequency reference, and also in order to operate, and also may the reconnection performance as well. So why this grid forming inverter matters to Minnesota? Because we have now more inverter-based resources in the system due to the expansion in the wind and solar energy, and we are retiring the coal plants, so we have less inertia, so we have a weaker grid, and also like the grid forming inverter better gives like better performance on weak feeders and during restorations. Another important uh, progress and development in the area of microgrid is the hardware in the loop testing. Um, it's basically like a flight simulator for the grid. You don't put a plane in the sky before trying it through a flight simulator. So the hardware in the loop tests the real control and equipment against a real-time digital grid model. This is what we used like in RTDS and Typhoon, the red and the black racks I showed earlier, and can safely simulate extreme events like fault, like lightning, like communication delays, and also like find protection and control issues in the lab. So we use this hardware in the loop testing to get like a lower project risk and faster commissioning and fewer surprises as well. So basically we have the real-time simulator, either the Typhoon or the RTDS one or the Opal. We have I/O interfaces, input-output interfaces, and we have some controllers, and then we have some measurement, and then we take that back to the simulator. So it's closed loop. So everything on the simulator, we can see what will be the impact on real life. One of the development in the application is the AI and data centers, which is considered as the new load reality as well. So the challenge is that they need large and fast and often 24/7 loads. It puts some stress on the power grid and the feeders and the interconnection. And also like they are training a new model. So you'll find a peak or a spike in the load usage as well, which can, if it get propagated through the feeders, it can cause some voltage instability for customers as well. There is a microgrid approach to deal with these data centers by having a dedicated microgrid for the data centers and has on-site solar storage, and the battery will be acting as a shock absorber to smooth the demand seen by the utility. This is what I mean by the load spikes. So the batteries will be able to absorb these spikes, and it has flexibility in demand, so we can shift non-urgent computing and cooling loads as well. So we have the utility feeders, we have the data centers, and we have the microgrid control and the storage, which act as a shock absorber. Another development in the area of the microgrid is what's called digital twin. Digital twin is basically like a virtual representation of a physical system that continuously receives real-time data to mirror behavior. So we use the digital twin in the center to test a microgrid behavior or performance in case we are introducing a new controller, adding a new equipment. So instead of doing that in the real life, we do it on a digital twin. And this digital twin showed like very close matching with the real world results. And we use it, as I mentioned, like in testing control strategies, predictive maintenance, and sometimes design validation and better decision via data-driven reliability metrics. So this diagram shows the digital twin of the CMR. So we have the control room or the control center, that the HMI that we have. We have here the main controller, which is called tertiary controller, and then we communicate. This is a real microgrid. As you can see here, we have the physical equipments, we have the batteries, we have the generator, we have the load banks, and we made a model, an equivalent model to each of these devices. And like thanks to the team at the CMR, the quality and the accuracy of the modeling match, like I would say 98%, 99% with the actual physical equipment. So
Hmm.
for us, in order to test a new control or a new protection, we can do that on the uh, digital twin microgrid, and before we implement on a real microgrid, which like the digital twin is computer based. And plus, it's a good opportunity for training. So if you have a new someone who recently joined us, so they give us, we ask them to deal with the digital twin before moving to working with the real world equipment. Say. Um, One of the needed um, area of improvement in the microgrid is the storage strategies, because we know like that most of the um, lithium ion batteries existing nowadays 2 to 4 hours max. So we need what's called long duration energy storage, LDES, and there are couple of options now under investigation. One is the hydrogen, either it is a gray hydrogen, blue hydrogen, green hydrogen, any type of hydrogen to store the energy during the daytime. So we use this extra energy in electrolyzer to split the H2O, the water atom, to hydrogen, so we can store this hydrogen. And this hydrogen can be stored in different forms, actually. And actually, we can use natural gas infrastructure to transport hydrogen. Another option, which is currently being investigated at the site of retiring Sherco coal plant in Becker, Minnesota, they are testing what's called iron air batteries. So this is a reversible concept, and when the battery charge, it turns rust back into iron. And when the grid needs power, it lets the iron rust again, releasing energy. So this simple process can provide around 100 hours of continuous power, enough to survive a week-long weather event as well.
Awesome.
Yeah. Uh, pathway. So we went through the technologies, we went through the concept of a microgrid. So now the pathway, how we are gonna able to achieve this 2040 carbon-free plan. Uh, so the goal is to choose actions that work across the future. So we have like scenario planning across demand growth, identify least regrets investment that good outcomes under many assumptions, avoid locking into expensive single track solutions. So this is very important because we need like flexibility if we are really want to achieve this carbon free in 14 years from now. Flexibility, we have to find lots of alternatives, maybe address all of them at the same time and choose which one will fit more. So delivering a flexible roadmap aligned with 2030, 2035, and at the end, of course, the 2040 milestone as well. And this is one also of the main
Mm.
tasks for the leadership in Minnesota is training the next generation of grid architects. So we have new students, and we want to train them to how to deal with these new technologies coming up. and things are changing very fast, and the progress is amazing actually. But I have lots of trust from like my position at the university. I see lots of bright future in the upcoming generation, for sure. When they get a task assigned to them, and when the task is specified, and you give them the moral support, they do amazing and impressive work actually. So, so the CMR, we always have like students working at the center. They can operate a microgrid. So we have undergrad students, second year students, they operated in microgrid, not just simulation. So, hand-on work, and we have a cross-disciplinary skill set, power electronics, protection, relays. We align with Minnesota grid needs, provide short courses, of course, and we have already industry-ready training models and local talent pipelines through internship and capstone project. Uh, One of the um, important aspects also, and Doug asked me to talk about it, about the startup companies in Minnesota working in this field of microgrid or storage or I guess I need to just adjust the slide number. So I want to start with this one. So these are some of the examples from Minnesota. We have Niron Magnetics. Uh, they make what's called like earth-free permanent magnet, iron nitride for EVs and winds. And we have liquid cool solution in Rochester. They have immersion cooling centers that can reduce data center energy use versus air cooling. And they have ENSP technologies in Minneapolis, which has an AI-enabled platform for the virtual power plant. And you have Carba also in the Twin Cities. They do carbon removal solution, which is very important in the hydrogen that can be used as storage. So the
Mhm.
Center for Microgrid Research had also like close collaboration with some of startup under Grid Catalyst, which is Minnesota-based company. They have a demonstration cohort program. So they connected the CMR with NeoCharge. NeoCharge is one of the is a California-based energy startup. They had their own software. They had to do some optimization related to the EVs and the operation of the solar and all of that. So they did all of these tests at the center here in St. Paul. So the results demonstrated that the optimized EV charging could be one of the most cost-effective ways to future-proof the grid.
Yeah.
And they have this study, it's published online. You can read the full report if you are interested. And also, it shows that good charging software can reduce peak energy demand by up to 45% and lower the energy bills up to 17% if you don't use solar, and it up to 26% with solar under time of use. And these two graphs, this is from the NeoCharge test. It shows the total power consumption during on-peak charging for Tesla long-range model. So the one in the red is with a new charge. You can see the cut in the power demand here happening in the evening of like 12-hour cycle. And here you can see if they use the solar aware software through the new charge app, you see a cut in the power exported to the grid. But this means that you are using your own power to feed your loads, either the house or the EVs and all of that. Um, uh, Conclusion about what I talked about today. So Minnesota 2040 transition is achievable with localized resilience. So the microgrid can protect critical loads like hospitals, like data centers, like bank server rooms, and support weak feeders. Digital stability, like the grid forming technology that's able to form the grid, voltage and frequency, plus the hill testing reduce the reliability risks. No regret planning for sure. Scenario tools guide investment under uncertainty. Ecosystem speed, startup plus pilots shorten time from idea to deployment. I thank you for your time and hope you enjoyed the presentation.
Wow. Awesome. Awesome. One question that went through my mind is, do you have any sense of how many quote unquote microgrids we have in Minnesota, for example? I mean, and would you count like the hospitals and places like that?
No, I don't have number. West is among the lowest in the US. Lots of investment in the microgrid industry and current microgrid in the West Coast, of course, like California and
Uh-huh.
Seattle, unlike Washington, Seattle. But the Midwest is among the lowest for sure. But no numbers in my mind right now. Yeah.
Okay. And the other quick question I had, the iron air batteries at Sherco, is that still going? I heard that the federal funding really slowed that project down. Is it still going? Or do you know?
I don't know, but last time yeah, I had like one of our colleagues. He used to work there. It was going till like the last few months. I'm not sure if something happened over the last few months, but or no. But last thing I heard, it was moving.
Okay.
Yeah.
Awesome. Okay, we're open to any other questions. If somebody has a question, please raise your hand. Louis, you're to begin one.
Actually, my question goes along with what you just asked as far as the iron oxide form company batteries. Um, Peter, do you have any feeling how good these batteries are? Do you believe that they might very well work?
Um, I'm not sure, but like research shows it's quite promising as well. Because Lewis, like the options for a long time storage, long duration storage are quite limited, you know. And hydrogen also has some challenges to be able to store in hydrogen, but we need like long duration storage. That's why they are investigating all the possible solutions. Uh, Efficiency of methods, I'm not sure about it, but we don't. What I mean is that we don't have much choices. We have
Jeff, go ahead.
Sorry, I was muted there. Uh, Great presentation. Hey, quick question. You mentioned Minnesota companies in the sort of the microgrid space and other kind of emerging technologies. But isn't there a big company here in Minneapolis called OATI that's big in microgrids and that sort of stuff? Or
yeah, yeah, that's true. Yeah,
do you know much about what they do?
They have their own microgrid also as
Okay.
well, and they do research related also to the control of the microgrid and the operation also of microgrids. Yeah.
Do you guys work with them at all or?
I joined 2 years ago. I always hear about them, but I never met any of them.
Gotcha. Okay. Thank you.
Yeah.
All I know about them is that they're a beautiful sight along 494.
Yes.
Yeah, exactly.
I always drive by.
Yeah. Peter, go ahead.
Yes, any good presentation, by the way, a lot of detail, but any support for microgrids at the federal level or in other states, be they red states or blue states?
Yeah, like the center, one of the main funding agencies through the Department of Defense, ERDC Lab, which is Engineer R&D Center at the DoD, U.S. Army Corps of Engineer. So we have like continuous funding from them, and we have also one of the part of the funding is coming from the Department of Commerce. Some of the Department of Energy fund got cut, Department of Energy, but overall things are Not too bad, let's say.
Not bad. Okay.
Yeah.
Thank you.
Frank, any
Hello,
questions? Any
I
questions?
have a
Oh, yeah,
question.
Kim. Okay, go for it.
Hi, how are you? Great presentation. Thank you, Professor, and terrific job on creating an absolutely fantastic Minnesota-born process here with your students and this whole microgrid concept. And I was going to ask earlier on, but you kind of sort of said it's possible. Is it really possible for us in Minnesota to be able to move beyond the coal plants, which, right now, from the federal government, there's emergency orders coming out saying we can't live without it, for energy security. I mean, what do you see? Is obviously that Xcel will be getting rid of their coal plants. They've agreed to it. The PUC's approved it. Going back, it's going to cost more for consumers. What? So, do you believe this whole transition is real truth, and we don't need those coal plants anymore, or are we maybe missing something?
You know, I I'll tell you like my opinion based on the research we see and the operation we see. Like retiring all coal plant is, is a very ambitious step for sure, for sure. The challenge will come when you have lots of renewable energy in your system. Either solar or wind, it doesn't matter, like any renewable energy, because this energy comes with inverters. Having lots of inverter in the system,
Cut out a little bit there, so you'll have to repeat that.
experience with having, and you are trying to push that to the maximum. Some technical challenges for sure, but the way Minnesota divided their plan, I believe there'll be some revision on the when you reach 2030 and 2035, when you have more and more renewable getting into your system. I guess if they will find more technical issues in the grid, in the power grid in Minnesota, maybe they will push it more and beyond 2040 to 2045 or something like that. Because at the end, like I'll tell you, like from my experience, I lived in Canada for a long time. The
Mhm.
most network or the power grid that has lots of technologies, top-notch technologies, is the Quebec power grid, which is the East Coast. Quebec is a province in the East Coast. It
Yeah.
has that top. Everything is new, everything is top and highest technology, but it has the highest number of technical problems at the same time. Yeah,
Isn't that France though, anyway? I'm a
yeah,
big Francophile. I know France a lot. I've been there 11 times. I'm in the Minneapolis Tour Sister City committee as well too. So I think it's great, but I just want to zero in on you. Do you believe that we are able to let go of our coal plants at Sherco and what have you, utilizing renewable energy microgrids? And of course, we have this huge amount of gas stuff, which hopefully doesn't, anyway, you've basically shown we went from coal to gas more or less
Hmm.
in the last 20 years. Yeah, can we drop the coal or no?
It
Are
could be
we able to
possible,
get
yeah,
rid
for
of it by
sure. Yeah,
2030? I mean,
it
that's
could,
the
yeah,
goal. We
that's
get
a goal.
this.
Like other countries worldwide, they did it. You know, it's not.
Yeah, I agree.
Yeah.
I agree.
So,
So,
so it is possible in
so
terms of it's possible. It is possible. Yes, for sure.
thank you.
Have you had any um, conversations with the Meta Center data center out in Rosemont yet? I mean, as far as their backup reserve for, their operation, I'm sure they're going to, run off the grid, but I'm assuming they would have to have some
Sorry,
backup just in case.
sorry, Doug, I missed your question. I couldn't hear it. There's some delay in the connection.
His question was, there's a Rosemount data center that's owned by Facebook, Meta, and they're running. Do you know anything about them and whether they're running a microgrid that runs sort of off the
Mm,
main grid? I
No,
think that's what Doug was
I have no
asking.
idea. I heard about this data center by Meta, but not sure how they power it yet. Yeah.
I did
Yeah,
want to ask you another question about I've been very impressed with that company that from Sartell that you mentioned, the one that using the iron ore technology, rare earth free magnets. Um, Tell me about what your thoughts on that are. Is how does it meet long-term storage, or how does it meet the needs, or where does it fit the niche? I think that's got a huge amount of potential for economic development in Minnesota because, of course, we've got the Iron Range.
Mm. Yeah, for sure. It's very promising. The technologies they are using, it's very promising, and its application also for EVs and wind. Because like the southeast part of Minnesota has lots of wind energy power generation. So they are startup company and they are doing pretty well. They need to keep the momentum to improve their technology for sure. And if they will be successful in that, they'll be like Microsoft of Minnesota.
Do you think though, like how does it play into your battery storage? You have lead. How does it compare to lead acid and your lithium ion batteries?
It,
Because isn't it basically it's what a battery? It's a battery concept, or no? Am I kind of missing that?
it is a battery concept, yeah.
Okay,
It's a
good.
battery
Okay.
concept for sure, yeah. But it will have
How
like a
does it
longer
compare to like
storage.
lithium
No,
ion?
it will be much better for sure.
Hmm.
Much better and longer duration storage, yeah, for sure.
another question I have is, can you hear me now?
Yeah,
I
I
can.
can hear you
Okay,
well.
okay. Are you guys working at all with like the U of M Morris? That to me is just doing some amazing work out there. I mean, a lot with hydrogen and alternate fuel sources, but it just seems like that would be an awesome place for a microgrid setup. You know, have you had any?
No, we don't have like collaboration with them, but we have very close collaboration with the Department of Electrical Engineering at University of Minnesota.
Uh-huh.
So, but I would be very happy, like if you can provide some contact, we can reach out to them and we can discuss any possibility of future collaboration for sure.
Hmm.
Yeah,
Yeah.
I could help with that, I believe. So, yeah, it's just I just think what they're doing has just been awesome. I mean, it's a lot to do with the hydrogen, like I say, and ammonia and that kind of thing, but they're just, it seems like they're way ahead of a lot of areas in the country. So,
Well,
That's
that's
well,
great.
we're a little bit past 7. Anyone have some final questions?
I have a very quick one.
Sure.
And I had been writing about geothermal for a while and making presentations about it. And I have an idea of how a microgrid could fit into geothermal HVAC, but I'm curious, how would you see that working, and is it applicable, and could it be
Yeah.
useful in a geothermal?
It has a very good potential, but for us at the center, we didn't get exposed yet to the geothermal
Mhm.
with the microgrid itself, but we saw lots of applications, including the geothermal in the microgrid itself. Like St. Thomas is the university is the local area at Summit Avenue.
Mhm.
So there are lots of restriction on what we can use and what we can't use as well.
Right,
Even like
right,
putting solar panels on top of the roofs of St. Thomas or the university, we have to take lots of permission because due to this nature of this area as well. Yeah.
right, right. Yeah, just in St. Paul, there's a number of geothermal projects, and maybe someday microgrids will be added to them.
Yeah, sure. Yeah.
Yeah,
Again, if you have any contacts, we will be happy to connect with them and see about we can share our experience, you can share their experience, and you can go from there. Yeah.
Mm-hmm.
Thank you, Frank, for that question, because that's what I was thinking about too. The
Mhm.
other one final question I had was, are you guys doing anything with St. Paul District Energy and what they are? I mean, I know when I was on a tour there, they were bringing in hydrogen and trying to test to, run with their feedstock and everything. Any collaboration with them?
There is no recent progress in that term, and even like we had collaboration with Excel Energy to help them operate and design 3 microgrids for some communities, like 2 Black communities and 1 native community. But this project is, let's say, it's on hold. uh, Lots of politics going on. So, but we have collaboration with Excel, not with St. Paul District Energy as well.
Yeah, well, I'm sorry, I got too many questions, but one other thing, and you already kind of touched on it, but you guys are predicting that the vehicle to grid kind of thing actually has some potential, you feel?
Yeah, for sure. I didn't include that in my presentation, but we are building now. If you drive by University of St. Thomas, you'll find a new building that will be housing some of our new equipment for vehicle to grid and grid to vehicle testing and operation as well.
That's
We are
great.
building a new building. You can see it, like if you drive by. This building can fit an electric bus. So we'll be doing research related to that for sure.
Oh,
And the
awesome.
opening should be in June of this building.
Oh, okay.
Yeah, yeah,
Fantastic.
yeah.
Well, thank you so much. This has
You're
been
welcome.
very informative. And,
Real quick, Doug. I'm sorry, Doug, real quick.
yep.
Professor, please tell me again what you just said about June opening. Is that Sabathani
Yeah,
Center? Electric?
no, we have at University of St. Thomas, we are
Mm-hmm.
building a new building. It
Mm-hmm.
will be housing some of the new equipment for the new microgrids we are building. We are
Mm-hmm.
building 2 other
And
microgrids to power South Campus building, like 9 buildings on campus, including the arena. So this
cool. And
building
that's going to have
will be,
electric bus, like you'll
yeah,
be able to go back and
it
forth on
can
the
fit, yeah,
grid.
it can fit an electric bus. So the plan is to have like research related to the operation of vehicle to grid and grid to vehicle as well. Yeah.
We'd,
Oh,
we'd
wow.
be, we'd be very happy to put out information on that when you're ready and spread it out.
Yeah.
We
For
get
sure.
emails out to a lot of people on our newsletters. So anyway, again, thank you so very much. This
You're
has been
welcome. My pleasure. My pleasure.
wonderful. And I appreciate you, talking about some of the other innovators here in Minnesota. That's very good. At the recent meeting last fall, I heard about the thing in Sartell and sounded pretty interesting. So they said it was really a major thing that it replaced the brewery up there that burnt down, and so now they've got something that will provide a lot of employment, which is part of making this all happen. So
Yeah, it'll be Microsoft of Minnesota.
yep, yeah, that's
Yeah.
exactly right. Well, thank you again. I'm sure we'll be in
Welcome. My
touch. And
pleasure.
yep, and for all the MRES people, as you probably know, we're going to start our board meeting in the near future based on an email that was put out with your time and connection. So thank you again.
Thank you. Thank you. My pleasure. Thank you all.
Yeah. Bye.
Have a great
Bye.
week. Bye-bye.
Thank you.